see. Let me see your hands. There we go. Tim, did you have a question?
No, there was no audio.
Story of my life. But you're getting it now, right?
Now we got it.
Okay. Appreciate it. I saw the hand, so which made me think, did I forget something already? So I appreciate it. Darlene, do you have a question? Or the same comment? Chat. Oh, I must not have clicked. I appreciate that. I forgot to check to click those buttons. So the chat should be live now. So again, it's been a start to a weird morning this morning for me, but I appreciate it. So good morning again. Hopefully the chat's working, and then you should be able. I'm going to put it in there one more time. The slides for this morning. So, knowing what we know and knowing how you guys know, I like to discuss any type of code conversation. Literally, I'm here for a local government summit, and I've brought the same slide to their presentation, just with a different background. But understanding the why behind the question is really one of those important things that we need to think about, and as part of this conversation. And understanding that why, I think, is going to be something that really is fundamental to figure out how we properly inspect. What are we looking for when we do inspections? And when we think about the purpose of and the intent of our construction codes, like the larger context of why we develop codes, is in order to provide that minimum consistency or that uniform consistency in how we build buildings and how we expect buildings to perform in order to maintain that safety, that life safety component. And life safety is not just this fire protection only conversation. It's all about the entirety of how we build communities. It's more about community safety, right? If we don't have energy conscious uh, policies, or if we don't think about, and what nobody thinks ventilation, how much air do I put into a room, in a bathroom, or a something like that, is a life safety issue. But in reality, it is about how that community is going to be successful. So when we talk about some of these expectations, one of the positive things that you have as a state is that you have a uniform statewide building code, right? And so you have uniformity, you have consistency in how we apply building code regulations. So again, energy conservation, energy use is one of those considerations within that system of building codes. And we know that the energy code specifically is less about telling you what to do and more about providing you the flexibility to do. I was in code development. I was in a hearings all week this week for different states and projects, and I was at my home state yesterday before I got on the plane. And we had this long discussion about what we introduce into the new model code. We're adopting a new code this year. Is and some of the things that were being asked of us to insert into that code were instructions on installation, not codes on how buildings should be built. Right? The energy code is designed to be that flexible resource to allow you innovative approaches and ways to get to what you're going for. It's not a simple, this is the only type of, to horribly use the concept of insulation. This is the only insulation you can have. That's not what the energy code is about. The energy code, and we'll talk about it in the context of our inspections discussion, is really more about how do you want to protect thermal heat loss and heat gain in this building. Is it through mechanical? Is it through the relationship between the mechanical systems and the building? Next month we're going to get into a little bit more of the mechanical. We'll talk about whole house mechanical. We'll talk about some of those things. But really, we all recognize that, or should recognize, that energy code compliance or general code compliance becomes on paper, right? It's knowing what are those systems, providing proper documentation. We had a conversation with a fire official this week where, why aren't you requiring more details on building plans. And it's, part of the reality is, well, because we don't know what material might be used, or if we make a change in the field, we don't want to come back and say, well, that material is not part of the prescriptive components of your construction details. So resubmit for plan review, right? We put general terms in like, manufacturer's installation instructions, because we expect that when they're installing it, we use the example of roof. Uh, Nobody ever submits into, typically, at least not in the plans I get, nobody usually submits on residential construction, especially, the manufacturer's installation instructions for an asphalt shingle roof. It's just not in there, right? We know that the instruction is on the actual bundle. And so when you go on site, it's going to be on the packaging how to properly install it. Um, and when do you put ice barriers or those kinds of protective drip edges and protect those drip edges against water infiltration? Those are all things that we understand begin or recognize through paper. And sometimes it's in, simple conversations. It's simple notes that say these items will be installed in compliance with the manufacturer's installation instructions. But ultimately, regardless of how good no matter how good a plans examiner you have, they're going to have to be a level of inspections required, right? The building code requires in section 15.14.5.3.9 gives us a list of different expectations and times when the inspector, the building official, is empowered to do inspections to verify that things are being done. And one of those items listed in the commercial code is weather resistive barriers and energy efficiency inspections, right? We need to be able to set up what are those expectations. If I'm going out and I'm doing a variety of different things, we're trying to talk about where are places where we can have that efficiency of inspection, not just energy efficiency, right? If I'm doing a framing inspection, if I'm doing a rough in for my mechanical or my plumbing or my electrical, there are certain things when I'm looking for those penetrations through firewalls or through whether that's commercial or residential or through wall assemblies or through different spaces, my thermal envelope. Those are all going to be times when I'm doing that rough in. I can look for the air barrier, right? You can see the potential there for that. And again, whether that's in the commercial code or that's in the residential code, we understand there are provisions provided for us to do those individual inspections. Now, throughout the context of this training course, we are going to talk a little bit more in depth about the different components in that inspection process. And as part of that unit, I just want to reinforce that we have our website that you can always find information on. Always trying to keep your attention on that because that's again going to be a place where we put some of these technical documents. And one of the technical resources that's going to be on there, or should be on there now, if not, I'll double check. I thought it was on there, but we're updating it. Right now it's for the residential. I think we're updating it for the commercial to make sure that's on there. Our different inspection field guides. Now I told you we're working on some for plan review as well. So those should be coming up soon. Let me see if I've got it in here. Field guide. I don't see it on there in my file. I'm not looking at the website. I'm looking at I'm not seeing it on my desktop. But again, those are going to be resources that you can go to kind of help guide. What are we expecting? And again, it's not so much from us as the inspector. I find this is a resource I like to give out to contractors. What are you expecting when I come back for a rough in? Right? If I'm doing framing, if I'm doing something, what am I going to look for as far as this? And then we give a little bit of description in that guide to help that process along. We also know that the state has a lot of great resources. So whenever you get it, most of you should have access, or I'm guaranteeing it probably more than once visited the state's website in order to look at different forms and application forms that they have there. But when you scroll down to the bottom, we have the checklists that exist, whether that's a thermal bypass inspection list, the duct sealing inspection checklist, different resources the state provides. And we'll discuss some of these in the context of today's class, but more importantly, we'll jump into these when we get to those sections of when we get to those specific components as part of our inspection series. But I just want to make sure that we understand there are plenty of resources out there to assist us, you know, to better navigate inspections. And if there are questions, if you have questions, make sure you raise your hand, put it in the chat, put in the Q&A, or if you have resource and technical documents that you want us to start to take a look at, always make sure you reach out to us so that we can facilitate those conversations and really make this more uh, useful and more efficient in how we operate our building departments. The last thing you want is to talk about energy efficiency, but then lose workflow efficiency, right? But getting back to this concept, this overview of what we're talking about, when we think about the primary components, or as I like to call them, the four pillars that are incorporated in that make up the requirements of the energy code, I tend to understand them. And I'm a very simple person. I like it simple. And so for me, energy code is these four things. It's thermal envelopes, it's air barriers, mechanical systems, it's power and lighting control, right? Those are the things that in my brain, every time I think about energy code, that's where my brain goes. How does this compare? Where does this issue relate to one of these four pillars? And it's in that conversation that we understand first and foremost what are the requirements to identify that compliance path. Um, whether we're talking about the way we design it, the way we review it, the way we inspect it, it's important to identify and know the compliance path because that's going to affect how we verify or scope our inspection process. Um, and it's one of those things again that the code provides. It's one of those requirements. It's supposed to be on details. But as an inspector, I need to know what the compliance path is because if I'm following a prescriptive path, we know there are three different paths provided in the code, and if I'm following a prescriptive path, right? Let me get my, I haven't used my pointer yet today, so I'll get my laser pointer out. If I'm using that prescriptive path, then I'm literally checking these things off on a box. Well, all right, I'm going through and I can use one of those inspection checklists. I can come back with a field guide or some kind of visual assessment tool and say, these are the things we're looking for. You're complying with everything. And so that's part of that conversation that we need to think about. Let me and again, when we think about it in how that's different from a simulated performance or an ASHRAE stand, or ASHRAE compliance in commercial, or one of those performance ratings in the residential side of the conversation, right? Well, in a performance, I'm not the only person verifying compliance, right? If you're doing a simulated performance, you've given me a proposed set of conditions, and then it gives you that flexibility, that trade-off to be able to come back and say, well, we're going to change this up and go this direction, right? We're still going to get the same target number, dollar value, or performance evaluation index, but you have a little bit more flexibility than when you do with a prescriptive system, right? There may be things that you have traded off in that process of performance compliance path decision making. That if I go out there and just say, well, I'm expecting R30 in every wall, right? I just say that's the number. I don't care what anything says. That's the prescriptive value. I want R30 in every wall, all 49 in every roof, right? Every roof. It's almost as bad as, it's the opposite of Oprah saying everybody gets a car. It's everybody gets an R49 roof system, right? If I go out there and then I find out that inspection expectation for prescriptive is different from simulated performance. And I'll tell you what, I'll be honest, as much as ASHRAE 90.1 is similar to the code, it is written completely different. And so for those of you that have not utilized or inspected to ASHRAE 90.1, it is a bear at times because you are looking at more than one section, right? We as in it as for me, I'm going to be 100% honest. As an iCode user, I completely understand the layout. Over time, I've learned to understand the layout of an iCode. When I go to a standard like an ASHRAE 90.1, my brain has to reset because of the way they've divvied up different responsibilities, whether it's in a section 0.4 for mandatory, 0.5 for prescriptive, 0.8 for performance inspections. All of those things come in, And that's important to understand. Now, the question we have, and one of the questions we have in the chat, if a submitter chooses prescriptive, do they need to submit the res check or com check? Actually, no. It's an option within within the prescriptive, right? So when you think about prescriptive compliance, and it's a great way to move to this slide, prescriptive compliance is perform compliance with all the requirements of these 5 sections, right? Especially in commercial. Now, residential, we know the energy additional efficiencies are not a part of the prescriptive requirements of section of for residential. But within that building thermal envelope, there are certain things we're looking for. A lot of time, a res check or a com check, which we'll be talking about more in a couple of weeks, is a great way to centralize plan review and changes to that insulation value. But res check and com check are really just a way to trade off or to more directly say, here's all the insulations that should be in this building. An example would be, and you see it a little bit more in commercial, I think, than you do residential. But you could say, here's my wall detail, and instead of every one of those 15 different, jump to it. I might have a slide that might help that conversation. So in the context of, I can have all these insulations options within my design on my sheets. And my res check is going to, or my com check is going to have a very simple evaluation. It's going to say you're going to have, a U factor of this, and it gives you that flexibility to change it around. Do we go with, and we'll talk a little more about that. But again, that's one of those things. But as a prescriptive path, you don't have to have res check. It's something that you're going to see when designers use it to help track how their walls are going to perform over different modifications. I had a project I was looking at last week where at the beginning of the process, the designer put together a com check. It was a hotel. They put together a com check. They gave that to the mechanical designer. Mechanical designer used that in order to determine how they were going to design the building for heat loss. The problem became, after 8 months of discussion and changes, the two were now no longer the same, right? The mechanical guy never got an update. The building plan started to change, and so then they updated their com check with different wall designs, but they never told the mechanical. And so when I finally, in the process of trying to clarify that with them, which took a lot more time than you think it would or should in that process, it turned out that yes, we were completely oversized in the mechanicals, and they're like, well, yeah, we can drop 2 or 3 ton per unit based on these revised numbers. And the mechanical engineer was like, I really appreciate this. This is gonna save the client money, but also make it to where we don't get in trouble for oversizing equipment and creating problems that somebody catches later, right? So hopefully that answers some of that, and we can always talk more about it later as we go through the rest of these slides. But again, prescriptive is telling me I'm going to be looking at all these sections and looking for those requirements and expectations. If I'm doing that performance, I'm looking at a report, and I'm just making sure that the minimum things of the report are in there, but there might be things that change in that report because it's really based on how much energy we're trying to, the cost of the energy of the building, right? And so you might swap out. You see here the mandatory, the requirements. Insulation is not a requirement. So is it possible that I could build a building that has no insulation? Absolutely. I could find a way to track that heating and cooling load and get it down to an all glass building, or that's why the code, and we can talk more about that later, but that's why the code says if you have so much glass, you have to move to performance, because it's not required to have an R49. I could go with an R25 and still be able, I could have my fire rated assembly style, fire rated assembly, and just call it a day and find a very efficient mechanical system, and probably come in and lighting controls and probably come close to getting what the code would require. It's all about flexibility, right? like I said, a little bit about ASHRAE. ASHRAE 90.1 has its own 3 processes: prescriptive, energy budget, performance. Very similar to our normal energy code, but again, it's a completely different way to look at it. And maybe someday if we have more questions or an interest level, let us know in the survey if there's an interest level. We could talk more about ASHRAE 90.1 as a code. But again, when we go to do those inspections, we normally, again, see them in these 4 different contexts, and it's all about understanding what those expectations are, right? That's why we've kind of broken our little guide there for residential and eventually for commercial into these different 4 pillars. You can tell who helped draft the first set, because I'm all about my 4 pillars or simplified designs. And so again, that resource is there. And if you haven't got a copy, I forgot to put it on my desktop. I'll make sure that if you want a copy of that inspection guide, let us know. But again, when you think about it, with the prescriptive process and the envelope itself, we're looking at a variety of different things, whether that's the wall, the roof, the fenestration, the air leakage of that envelope, because we're really trying to control the envelope and how it affects heat loss and heat gain. Right? We know the envelope is the building's exterior wall envelope is defined in the building code as that series of materials and components assemblies that protect or provide protection against the effects of the exterior environment, prevent the rain, right? The rain that just came through the Panhandle and maybe part of Clovis, right? In this northern part of the state. I was able to stand inside the building and not get affected by that rain. However, I am not as sure that we're protecting against the thermal envelope, because I can feel the humidity of that rain inside the building, right? That's where we get into the building's thermal envelope, which is trying to enclose that conditioned space and isolate it so that when I sit in this room, I'm not affected, or I'm less affected by the 84-degree temperature and high humidity right now outside, right? And so again, that's the difference between a wall envelope and a thermal envelope. One is to protect us from the environment. The other is to enclose and isolate conditioned space. And so again, think about those when we think about our inspections. Are we looking for the wall envelope? We're looking for that thermal envelope. And this is probably one of those great places to remind us, that the code gives us ways to lay out those different assemblies and the insulation that we associate with them. And I find it a lot of times easy to relate to our fire rated assembly, right, concepts, and so some of those expectations about the continuity that we see within fire rated assemblies, we need to see that level of continuity in air barrier and thermal envelope design. And so a lot of times in commercial, that's a little easier than in residential. One of the things we're going to be doing here in Amarillo at one point soon is trying to set up a building community coffee or coffee and code conversation, where we're going to go to a house and try and smoke it out, right? My plan is to do smoke barbecue and smoke the house, right? Make it a smoker's day. And that way we can have some food while we watch the building pressurize, and then see if there's air leakage and how much air leakage are we having, right? And so those are, again, good things to think about when we talk about those inspections. And we'll get more into those air barriers and insulation later. But again, when we think about our inspection field guide, the way we kind of laid it out was, again, based on my expectations for inspections, right? I typically do footers and foundations, right, at the beginning of a process. So I've separated those out, or we tried to separate those out and say, hey, depending on what we're doing, what's been approved, and where's it at on the approved plan, right? This might be something where, again, you mark it down and say this is on, A3, or and we don't have a heated slab. We're doing basements versus a floor or a slab, whatever, what might be appropriate. And then what did we do to verify those things? So again, this is just a simple resource where we put together to help. Similarly, when we start talking about those framing inspection, those rough ends, what are we looking for? We're looking for that bottom plate. We're spending time looking at it to make sure it's connected to that foundation. It shouldn't be too much. It would be very quick for us to say, where is, while I'm looking at the bottom plate, looking for the right connections, or whether we're bolting or whatever we're doing, I'm looking at those things and saying, okay, where's my weather stripping? Where is my gasket? Where's my ceiling to make sure that we don't have air movement through those systems? When I start thinking about penetrations, where am I sealing? I'm looking at those cavities. Hopefully, we do we do a framing and rough in prior to installation install, right? So I'm going to see it without, smoke it out. I like it. Joyce, you might get an invite now. Uh, but maybe we do it again over in one of our New Mexico communities. We will. I bet we can get somebody to host us if we're going to bring barbecue. Just saying. Uh, but again, think about it in those contexts. How do I do a framing inspection and then roll in my energy efficiency components? We don't want two inspectors looking at the same thing. We want one inspector doing the job. Um, and again, thinking about those things and other insulation expectations. And we're thinking about the ducts, whether they're going to require insulation or not. If we're doing sunrooms or attached or detached garages, we're looking at those garages, looking for that firewall separation. Why don't we make sure we verify that we have thermal isolation as well? And remember, when we talk about these types of things, I need to probably go stop opining on the conversation. But when we need to understand that there are a variety of materials that can be used to insulate these wall systems, which is why compliance paths are so important. We could start to see some trade-offs and some movement within the material as long as we understand how it's going to affect the building, right? And knowing that is also going to be kind of to the point we had earlier with whether or not we use the res check. Am I doing this compliance based off an R value, right? If there's an R value, then I'm going to look at this particular table. Whereas if I'm using a U factor, right, there's the R value. If I'm looking at a U factor, right, which is looking at the whole assembly, not the individual cavity material, but the whole assembly, then I'm going to be looking at a different table in the code, and more importantly, I'm starting to get that flexibility, right, and how we calculate. Remember, the U factor is a calculation of all of the materials within that tested or evaluated assembly, right? You can get that. There's a million different resources, ways to find it, but in this process, we're adding together a wall design to get to a area weighted U factor, and but then we can also start to move and change things, right? We can start with an R13, and that R13 gets us to this 0.057. But what if I change that to an R17, right? Enough. What if I don't go to the R30, which is 0.045, but I want to go to an R20 with 3.5 continuous? Can I do it? Well, there's a prescriptive way to do it. Yes. There's also through the R value table, and there's a U factor way to do it through the U factor table. So again, providing that flexibility, but that's not the only way we see it. Kind of like we were talking about, res check, com check come in. And they're not the only ones. Those are just free options on how to provide that total UA. Different wall companies. We've shown one from Dow, I think, and I can't remember the other one, where they'll actually help us create those. I think we've talked about resources during our insulation deep dive conversation about ways we can, include all those components to calculate, when do I need an air barrier? What type of material am I using for insulation? What's my wall size? And then what is my calculated U factor? Again, it's math, it's not science, right? And so it's part of it is, finding the right calculator to get you that information. And whether, again, we're going to have something that's very simple that says we're doing a 16 ounce center steel frame, which if I had moved that, you'd be able to read what's behind it. Or if I'm doing something like this, where we see a steel framed, we got the performance, we got the proposed design, an 11 bat with a R10 rigid, right? And that's still going to get us to a 0.057. And so again, what are we trying to, we have that flexibility. And sometimes those com checks, those reports are going to be used for us to say, okay, what different options do I have within that insulation variable? And again, we can see all kinds of different insulation schedules. I'm seeing more and more where designers are taking. I'm not saying it's the easy road, but it's the load. It's a little bit more less paperwork, where we're seeing insulation schedules put into the document, into the spec sheets up front, right? Those notes, and then The detail pages are all saying refer back to that page page T3, page H or G2, right? The table in, so that they're not going through and recalculating all the details and saying, okay, because there's going to be some plans examiner like myself who says, well, detail 3 on page G6 or A6 does not have the does not is not consistent with detail 4 when it comes to insulation. Yeah, we missed that one. So again, you'll start to maybe see tables that start to show up to allow for that flexibility in that design. And so we'll talk more about that as we go through. But proper installation, proper inspection means knowing what those things were, making sure they're on the plans. Because again, I can't do it if it's not on paper, right? If I don't have something to hold them against, then when I go out to do my inspection, how do I know if it's been properly installed? Is it, how much overhang are we supposed to do? How much protection against construction site damage versus traditional walk space damage, right? Gaps that might start to exist. The expectation in the design is we have consistent, continuous insulation. When we start to see these gaps easily at one stage of development of construction, whereas later in construction, well, wait a minute, you didn't fill it in, and come back with a thermal, and I can see where those gaps are. We can see the impact on different ways of installing insulation in order to influence or change heat gain, heat loss, right? This is an example of a steel building that was post construction installed some insulation um, in order to reduce heat gain. Outside temperature was 116, inside wall temperature was 102. Why the change? No, most of us know, as you can see by the next picture, most of us know that system is going to retain its heat. It's metal, it doesn't have bridging, especially on an exterior wall of a metal building. But by insulating, we're controlling some of that heat loss. And again, they can come back, and this is a semi-heated space, so it wasn't a huge deal. Some of you may know where this is at, but if they were to install thicker insulation, they could control that heat differential and more effectively, more efficiently. And you can kind of see here, this is an example of the picture and the thermal camera image. And so you've got these skylights that are providing some natural light at 160. I didn't have the screen on it, but it was like 116 to 120, 116 on the wall on the orange, and like 120 on the white. But the interior wall where we've got the bad insulation, the cavity spacing in that liner space, we're at 101. So again, we're controlling some of that, and we can start to see where we've got it. And again, this would be if this was a new construction and my details said to have this, or to have that thermal bridging, this would be a great way to show it's not working. You didn't install the right spacer, because I'm still getting huge amounts I'm not getting any dissipation or change in that temperature. So again, I don't have to jump on the cherry picker, the ladder, the lift, and go up there. I can sometimes do these through that simple devices, tools, and resources that we've shown you before. Whether again that's a whole handheld camera, the little one that I keep bringing around to my bag over here. But again, I can see different levels. This is in a drywall separating a garage from an interior space, and we can see where there's a cavity missing insulation, and we can see how that's impacting that wall. And again, what we're trying to do with this entire building thermal envelope is all about thermal loss, protecting or thermal loss and heat gain, right? And so if I'm losing and gaining heat through this door system or through some corners that aren't properly sealed or continuous in their protection, then that's going to be what creates condensation, and it creates also the greater need for our mechanical system operation. Again, some more examples of that. And when we think about our visual checklist, again, we'll walk through this a little bit more when we start talking about it in the direct context of insulation inspections. But again, we can verify some of those air barrier envelope components using our checklist, right? But it all comes back to what are we expecting to accomplish out of this envelope? And remember, the envelope is not just the wall, not just the insulation, it's the fenestration and making sure we have the right doors and windows and skylights. They have the right, it may seem like a simple set of components, but the proper installation of these types and the right proper installation and the proper material selection for thermal resistance ratings can have significant impacts on how the equipment is sized, the occupant health, uh, and 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 again, what we see there is again the U factor, which is a calculation. The two main methods we see with most windows, fenestrations, doors is going to be the U factor, which is going to be the how much heat transfers through that material over time, versus the solar heat gain, which is again how much solar radiation itself impacts interior design temperatures. Now, remember, when we're talking about commercial specifically, we get into projection factors, but that's not necessarily something we always see in residential. So that's going to be a separate discussion when we start talking about fenestrations in a couple weeks as part of that inspection and design series. But again, we can see how the glass can perform to restrict the movement and proper sealing, proper flashing, right? Those are ways to control air and moisture flow in these areas of what I call first deterioration. Uh, that's going to be one of those places where, um, we're going to see the type of deterioration that can be reflective of poor installation. Uh, and again, we can test those different systems, whether they come as a unit from the store, or we can test how we're testing them and what those expectations are if they're site built, right? We don't just want to confirm the thermal resistance, though. We're looking for both thermal resistance and air leakage, because just because you have great solar heat gain and then you have cracks all around the window, you're letting the air and the heat through. You have to look at both of those systems in concert. And a lot of that comes back to, again, having proper detailing. Where am I supposed to be looking for? This is almost as much of a conversation for installation or contractors as much as it is for inspectors. Because if you have the right details, the right sealing expectations, then you'll know where you're supposed to be looking for, where you're applying that sealant. Because again, air barriers can't be an afterthought because air movement has consequences, right? We know that air movement affects a variety of different things, from water and vapor transfer to the indoor air quality, right? Smoke, smog, exhaust, humidity. All those things are reflected in the movement of air through these types of assemblies. And most of us have been in this business probably long enough to know when we see something that just wasn't protected properly against moisture transfer or heat transfer. And the code provides us, the energy code provides a long list of considerations for testing and how to prevent or mitigate control. My favorite C word for codes, it's not codes, it's controls, right? And we prevent this kind of air leakage through the building envelope. And we provide in that inspection guide a list of, and it's pretty long, but they can be broken again into several categories. And again, our list is not an exhaustive list or categorization of it. I tend to, again, focus them in these general five. Again, like I said, I'm simple. So to me, it's the general things, the electrical pieces. So when I'm doing electrical rough versus a plumbing rough versus, just general when I'm looking for fire or separations or thermal separations between conditioned and unconditioned. Again, this is when I'm looking at these things, or utility shafts associated with my mechanical inspections. So for me, this is one of those, depending on who's doing those inspections, I might carve out different pieces of this to reinforce, my electrical guy. Hey, when they're putting in boxes, making sure we're sealing, not just for fire, but also for moisture, making sure we have the right boxes so we don't have air transfer, right? Same thing with plumbing fixtures. If I'm doing the plumbing and I find I've got a bathtub or stall along an exterior wall, I need to make sure that's properly insulated, not just to prevent moisture inside the space, but against that interior uh, enclosed or space, right? That unexposed cavity that's going to exist between that tub and the wall. So again, that's kind of how we've broken some of those down. Again, we'll break in these a little bit more as we start talking about more specifically the role of maybe an inspecting during mechanical installation and how utility shafts and thermal separation are important there. Again, for me, thermal separation is one of those things that's, if I know the garage is not conditioned and I know that's going to be a place where I'm looking at it for multiple reasons. I'm going to make sure I'm paying attention as an inspector to make sure that we have good air control in those areas, especially if I'm transitioning or thinking about it in a commercial context, where I've got storage spaces next to office spaces. Many of us have worked in buildings or maybe have visited buildings where the office is always, the office staff is always complaining that it's too hot, too cold, because they're adversely impacted by the neighboring non-conditioned space. And so that's why we end up having fire safety issues with plugged-in heaters and coolers and all that kinds of stuff. More heaters than not. But overloading electrical systems because you've got 15 fans or 15 space heaters because you just don't have good control over that conditioned space, that air barrier. One thing that we have to ask ourselves in the process of inspection is what type of testing is going to take place. Is there going to be testing? We through the when you think about it through the state's visual inspection checklist, we recognize that there are not testing capabilities, testing agencies, or capacity in every jurisdiction. So are we doing testing, or are we doing some type of verification, either through visual or through the checklist or something like that? So again, there may be requirements that under other compliance paths, which again tries to drive us back to that compliance path. Based on that compliance path, I may have to exceed the code minimum air leakage. I had a project the other day. It was a building that was trying to use a performance path for residential, and the performance path said that I needed 2.2 or 2.5 air changes per hour. I think it was 2. The code said 5, and so the mechanical design and the contract itself, the actual documents said 5. And so it became this, well, which are you doing? Because if the building construction documents tell me 5, and the mechanical design is expecting a building that has 5 air changes per hour, what are you? But your compliance path option is 2 to 2.5 air changes. What are we doing? Because you're going to have a system that's sized improperly. If I'm changing out the air twice as much as I should, or allowing that building to leak enough that it changes twice as much, have I oversized that piece of equipment, right? Or is it undersized? If what's the expectation of the installer? He's expecting he's going to test it. He might throughout the process. You never know. Some designers, some contractors actually carry their own blower doors. I've talked to a few here in Texas. They have their own blower doors, and so they may go and say, "I'm going to test it myself before I pay for somebody to come out here." And so they test it and they get a 5 because they're looking at the construction documents. But then they don't look at the report, the performance report, the ERI, the whatever the ecotrope rate, M rate, rim rate, whatever that report is. They're not looking at that report and they're saying, which says 2.5. They think they're done. We've got 5, right? And then or we've got 4. Let's say we have 4. Well, then the actual testing company shows up, says, well, no, you didn't get it right. Either do it again, or we're going to have to derate the scale, and you may fail, right? So this can have a significant impact on compliance. The compliance path is going to have a significant impact on what we're expecting out of field testing, verification, and then, like I said, as an inspector, I'm doing my part to make sure everything is properly sealed as part of that air control system. And sometimes, again, they're walking around doing that visual assessment. I kind of talked about these a little bit earlier. If I'm looking at this, if I'm doing my framing and I'm looking at how that sill plate is connected, that bottom plate is connected to the foundation, and I see this, then I can very quickly say, hey, we need to figure this out. What are we doing here? Right? We're going to have moisture and air movement. If I'm doing my mechanical installation inspection, I'm going out and seeing the compressor, I'm seeing this conduit going through the wall. I'm going to say, what are we doing to seal this? And if I'm doing that sealing process and I'm seeing this, I've got more comments and questions coming after, right? So again, whether we're talking residential or commercial, how are we being tested? How are we being verified? Maybe I should have moved that slide up earlier, talk about it, but again, insulation is not the end of the conversation, right? And we will spend plenty of time talking about this in greater detail, but mechanical systems are a critical component. And you know how I like to keep it simple. I've had several people suggest that it's great to have this consistently reinforced. Keep it simple, right? It's calculation, it's distribution, it's equipment selection, it's controls, right? Four basic concepts when it comes to mechanical. That's true in mechanical, let alone, energy mechanical, right? But these four main subpoints within the mechanical system, again, we've tried to lay out in our inspection guide and in our plan review conversation guides. But there are plenty of options on how to verify this beyond what we've suggested, right? Making sure as an inspector, um, if you're telling me that this building, this is the area that needs to be conditioned, and I see a pipe chase or a duct going somewhere else, I'm going to ask, where's that going? Oh, we don't know. We just put it to that room. Well, that room's not supposed to be conditioned, is it? So you're adding more discharge than what that fan was designed to put out. You're going to affect how that fan's going to work, right? Or the exact opposite. You're not conditioning this space, which is supposed to be. I had one that was here recent. It was a very large building where they were calculating equipment size based on different designs, and they had calculated this piece of equipment based off of a gym at the end of the project. And I said, well, I just asked the clarifying question. Am I right to understand you're using numbers RTU 7 to condition the gym when you've got some RTU 13, which is right next to the gym? Are you sizing these right? Oh, we didn't think about that. Yeah, that makes more sense. We should do that. So let's take the 135,000 BTU off of this one and put it on that one, right? Instead of running a 25-foot long, you know, trunk or supply line in order to service a facility that you're just going to have thermal loss over the process, or more impact on airflow, right? So again, these are things that energy code can assist in evaluating traditional mechanical. So again, those are things that as a are important. And again, where's the duct's location? Does it need insulation? What type of leakage are we expecting? And like I said, so it's equipment, distribution, controls, and then equipment design, right? Did we properly design it? The thing you don't inspect. We don't inspect the design as much. But one thing you could see is, if we design this building to be, 3,000 square feet, and you show up and it's 30,000 square feet, they missed a decimal point. That could affect a lot of things, right? If you show up thinking this is going to be a Starbucks and they turn it into a happy walk, you may have different ventilation requirements, right? Or again, if it was designed as an office and now it turns into a retail space and turns into a tenant changes it out and comes and creates a new hothead burrito or a Chipotle, right? You're going to have ventilation issues that are going to be completely different than a traditional retail space. And so how are those things being evaluated? How are we controlling for that? And how is that going to affect things like the water heating systems, right? Maybe not so much in the warmer climates of Hobbs and or Roswell and Artesia and Carlsbad, but maybe in the northern parts of the Taos Valley, you may be thinking about snow melt, but or again heating those pools. That might not be something we think about today. I was doing a project where that is definitely going to be a problem. They want to heat a pool. Well, guess what? You just can't. That just doesn't. They're like, well, that'll be a deferred submittal. Yeah, but you're putting the piece of equipment in now, so it's part of the building, but you're going to run a pipe out there. So let's talk about it now. So sometimes I get in more trouble than I should. But again, part of that inspections that we associate with mechanical systems is going to be knowing what's going to be commissioned. What am I inspecting for as far as proper installation versus there are things I'm not capable or qualified to do commissioning. Is it working right? Do I functionally test who's testing all the circuits and the controls to make sure they work? Right. I think of the same thing when we start talking about, new equipment. I think of the A2L refrigerants, and we're installing a sensor to detect certain types of refrigerants with have been leaked, and that is supposed to then create some type of action. Well, who's testing that? Right? Those controls need to be tested, And sometimes that practical functional testing and equipment or control commissioning is important. And again, for us as inspectors and plans and building officials, we need to know that information is there and that's coming to us. But again, from an inspections perspective, I like to always verify that the design my inspector, my plans examiner hat. Again, like you guys know, most of the time I've done all of it. And so I've done some inspection after I've done the plan review. So I walk into a building knowing that I'm expecting office space versus uh, service bays versus other things. And so I can say, well, this doesn't match with what you said, right? I can see that I know what uh, that schedule says for the equipment efficiency, and what I'm seeing in the field is not the same. So let's talk about that. What are we doing, right? And again, same thing with the heating systems and the ducts that we see, where they're located. We need to inspect for proper installation of those duct systems, as well as the insulation associated with those systems, and the controls that go with them, right? Making sure we have, if we're going to have these units in different locations, where are those controls supposed to be located? How are they going to be incorporated into the design? Like I said, there are some considerations for water, maintaining water temperatures, and preventing uncontrolled condensation associated with how different piping systems operate or boiler systems operate. So again, those are things to think about when we're doing those inspections. We'll got a few minutes, so we'll finish this out with this concept of power and lighting in real life. The last pillar that we talked about was power and lighting. And that power and lighting is all about understanding the amount of allowable power that can be used for lighting, right? We're not talking about general electrical operation. We're talking about lighting systems. Now there are direct demand response controls that are starting to move into that conversation about how do we manage overall power. I'm always interested in how those conversations go. I was in a code hearing on Tuesday, and there was some overwhelming support for creating. I tried to stop it, or I didn't right say stop it. That's not the right word. I tried to provide some practical experience on proper location of demand response controls or occupancy based demand response controls, and what I've seen in observation, where people will choose to just plug everything else in another receptacle. Then, if 50% of my receptacles are going to be controlled, tell me which ones they are, and I'll plug everything else in the other one and overload that receptacle, right? Digression nonetheless. But there's a lot of people that want to push that. Maybe it's moving beyond just the power and lighting and moving into overall power consumption. So in that conversation, there are some things that we've tried to easily summarize, right? But it's all about knowing that there was a calculation, knowing that the area matches the calculation details. And then it gets into the proper lighting installation and controls. When do we need occupancy sensors and what are they supposed to do? Again, you can maybe identify where they're needed, but there may be some limitations on their ability to say they're actually functionally capable of doing what they're supposed to, right? Are they actually controlling? Do you sit there and start flipping the switches and seeing which ones, alternate luminaires versus lamps? Do you play with the dimmer, or do you require some type of testing, right? Especially when you start talking about exterior lighting systems. Again, we'll talk more about those inspections. I can see the light is there. I am not any longer. I've moved on in life to where I am no longer responsible for making sure that the equipment shuts off when there's no light, or turns on when there's no light. That's probably the better way to put it. Turns on when there's no light and turns off when the daylight's out. Now, daylight I can usually see, but depending on the level of glare, I don't. I bought a NIT um, monitoring tool, one of those nice long ones that you can aim and you can tell the nits coming off a lighting system. That was expensive. And as a jurisdiction, it was something, why are we paying for that? Have the contractor go and get an inspection done. Have them pay, and that's probably a bad attitude, but it's one that I think is real. We know there are certain things that need to be tested in those exterior lighting systems, and I'm not going to send a seasoned inspector out to sit out at 10 o'clock at night and see if the lights turn off. It's important. And so I need you to do some kind of work to make sure it's working properly. And then again, those automatically turn off. And so not only is it in the controls, but as an inspector, I'm making sure they're wired. And I'm going to ask that question as we're installing all these lights. So where's the one with the sensor? Oh, it's this one. Okay, well, at least we know you know, and that you know I know. So let's make sure it gets wired properly. We know that inside that context of power and lighting, we get into the idea of the EV power infrastructure again. And so as an inspector, I'm going to be verifying a little bit more um, than probably previously before 2024 that we've got the right, that you've installed the right uh, raceways and capacity for these different EV capable spaces, right? And so again, it's part of that relationship. And so you may end up having conversations where, hey, where's the EV on this, right? Again, this is a little bit of a unique thing, but it's becoming more and more prevalent where this is being integrated into design conversations and code adoptions. But more importantly, we want to make sure that we think, how is this being installed? Where is it needed? And where am I, how am I verifying that as an inspector? Again, remember, this may conflict with other local expectations, but remember, it's uh, the most intense of those two that's required. So if the energy code says I need to have 15% in an R2 occupancy, but the zoning code says I need 10, then I need 15. And if the zoning code says if the economic development zone, right, some CRA that I'm moving into, some unified plan set, some plan development requires 30%, then I go 30%. I have to at least provide 15 as part of the state's the code requirement. Um, whether that, and so if the local zoning is, or local regulation is lower, then I go to the state. If the local is higher, then I can just go to the local, to the local. But it's the minimum expectation to have these uh, number of spaces. I got 2 minutes. Um, Remember, there are other things that we're going to be looking for in this process. Not every building has an elevator. Not every building has an escalator. But so we're going to look for those kinds of things as they come up. We put that in the list, and we also provide a list of additional efficiency options. Again, as part of being in a commercial project, there are certain things that we're going to be doing that's a little bit different, and so we need to make sure those are probably documented on the plans, so that if I'm in the field, I can make sure that I'm looking for some of these things. Some are easier to see than others, but again, am I doing some? Part of that is knowing our limits, right? And that's knowing there are certain things that we can do, certain things we can't do. But we do need to always know where that thermal envelope is located, what we're doing for that air barrier, uh, how are those materials being installed, and then to what degree can I, as the inspector, understand what's on those plans, right? But recognize there is a future, there is new technology coming out, and so that's part of this conversation, and what we'll be looking at in the future will be a whole new conversation as we all walk together. Now, we got 30 seconds for Q&A. If anybody has any, obviously make sure you throw them in the chat. Next week, Andre will be with us to talk about air, water, vapor barriers. Then we'll be coming back on the 31st to talk about breaking down the res check report specifically, looking at a couple different examples, how they're used, how they're calculated. I just got off a phone call with P&L Tuesday, where they're trying to do some upgrade dates and upgrades potentially. So we'll talk a little bit about that, but more importantly, we're going to look at how does this look in the real world, pulling up a bunch of res checks and comparing them and talking about how we can comment. Then we'll get into mechanical systems. Like I said, there's a lot of great conversation there coming up. If you do have topics you think are important, make sure you put them in the survey. If you're interested in hosting one of our future in-person trainings or one of our community coffees or our energy code collaboratives, please make sure you reach out to us, let us know. Keep an eye for those kinds of things. And as always, you can use our helpline to find different information on the different program. But if you have questions, if you have a contractor, a designer, or you as a code official have questions, need assistance, always reach out to us. We're usually available 9 times out of 10, but by using that, it goes through the entire team, and somebody can respond back to you. If you do have any questions, always email us, reach out to us. I appreciate you guys all being here. So if you have, if nothing else, be careful, be safe, have a great weekend, and I will see you again soon. See, it looks like I got a Q&A in there. Oh, nope, I already answered that one. See if I can stop recording somehow. There we go.